the force inside the device pushes charge from B to A against the direction of the electric force, this non-electrostatic force. Then maintains the potential difference between the terminals. If it is not present, then charge would flow between the terminals until the potential difference becomes zero. So it depends, because this is an external source, mm, it depends from where, it depends on the source, which kind of source we are using. In a generator, it results from magnetic forces on moving charges. In a battery or fuel cell, it is associated with electrolyte or different processes. And in electrostatic machine, such as Van de Graaff generator, and actual mechanical force is applied by a moving belt or a wheel. So this non-electrostatic force is dependent on which source we are using. Now, if a positive charge is moved from B to A inside the source, this force Fn does a positive amount of work. We write is Q E on the charge. This displacement is opposite to electrostatic force Fe. So the potential energy associated with the with the charge increases by an amount equal to Q V A B. We can write it for positive charge. So this is work due to external force N on Q, and this represents the potential, this term. So the potential energy associated with the charge increases by an amount equal to Q V A B. We know work is equal to potential energy charge is equal to U, or potential energy is equal to Q into V minus VB. So F and work divided by Q is equal to potential difference. And this potential energy is associated with a charge increases by an amount equal to QVAB, this one, and AB is VAB is VA minus VB, is a positive potential of point A and with respect to point B. So for the ideal source of EMF, we can say that FE and Fn are equal in magnitude but opposite in direction. So the total work on the charge Q is 0. There is an increase in potential energy but no change in kinetic energy of charge. So it is like a lifting a book from the floor to a high shelf at constant speed. The increase in potential energy is equal to the non-electrostatic work, this one. You can say non-electrostatic work, and Q is equal to QE, and it becomes EB becomes an ideal source of EMF. So now let's make a complete circuit. We're connecting a wire with resistance R to the terminal of the source. So let's complete this one. So the potential difference between the terminals set up by an electric field within the wire, and this causes current to flow around the loop from A to B or from higher to lower potential. And the potential difference between the ends of the wire is given by VEB is equal to IR, Ohm's law. And here, by combining these two equations, E to VEB is equal to IR. So when a positive charge Q flows around the circuit, the potential rise E as it passes through the ideal source is numerically equal to the potential drop VAB is equal to IR as it passes through the remainder of the circuit. So once E and R are known, this relationship determines the current in the circuit.